A very good morning, everyone. Greetings from Visvesvaraya College of Engineering, Mysuru, and National Institute of Disaster Management, New Delhi. I am Raghavendra S. Sanganaikar, Assistant Professor, Department of Civil Engineering, Visvesvaraya College of Engineering, Mysuru. Extend a warm welcome to all the speakers and participants for the Day 3, Session 1 of Day 3 online, 3-day online training program on Fundamentals of Disaster Management, which is being held from 15th to the 17th of September 2021. Dear participant friends, we have with us one of the most famous personality and our very own Dr. Eske Prasad. The speaker is going to talk about earthquake disaster risk management. It's a great honor to have you as a speaker today, sir. A hearty welcome to you.
Thank you, Professor Raghavendra.
I also welcome today's panelists, Dr. Chandan Ghosh, Professor from NIDM, and Dr. Umesha PK, Professor and Chairman of Research Studio, VVCE. Welcome to all professors.
Thank you.
I welcome all the coordinators from NIDM to the and organizers from VVCE Mysuru. Most importantly, I welcome all the participants for the today's session. Now, let us start with the brief biodata of our today's speaker, Dr. Eske Prasad. I call our final year student, Ms. Harshita, to introduce the speaker. Over to you, Ms. Harshita.
Okay.
Thank you, Raghavendra sir. Good morning, everyone. Dr. Eske Prasad is the professor and head of civil engineering at Visvesvaraya College of Engineering, VVCE, Mysore. He worked for 32 years at Sri Jayachamarajendra's College of Engineering, Mysuru, and 3 years at MS Ramaiah College of Engineering, Bengaluru. He obtained his bachelor degree in civil engineering from the University of Mysore, securing first rank and 4 gold medals in 1982. He obtained his master degree in geotechnical engineering from Indian Institute of Technology, Kanpur in 1985 and doctoral degree in 1996 from University of Tokyo. He was the visiting teacher 2000 from Indian Society of Technical Education, New Delhi. He was a visiting assistant professor at Asian Institute of Technology, Thailand for January 2006 term. He has published over 175 technical papers in national and international journals and conferences, guided over 70 master's dissertations, and guided 3 doctoral students. Presently, 3 more students are working for PhD under his guidance. He has completed several sponsored research projects from JSS, MFE, AICTE, and DST. His areas of research interest include earthquake geotechnical engineering and performance-based design. It's my privilege to introduce you, sir. I heartily welcome to the session, sir. Thank you.
Thank you, Harshita. Thank you, all my
Thank you, Harshita. Thank you, Ms. Harshita. Before I hand over the session to the speaker, we have a few things to announce to the participants. Dear participants, as you all know, as part of this 3-day program, we have quiz competition, which is being provided along with the feedback in each session. So don't forget to give your valuable feedback. Secondly, if you have any queries to the resource person, you can post them in the chat box along with your name and place. Those questions will be taken up by our panelists after the presentations. And feedback along with the link questions link will be posted in the chat box towards the end of each session. Dear participants, kindly note that the e-certificate will be issued to those who have registered in NIDM portal and on submission of all the session feedbacks. Without further delay, let me hand over the session to Dr. Eske Prasad, sir. Over to you, sir. Sir, over to you, sir.
Okay. Thank you, Professor Raghavendra. It's a pleasure always to be, associated with talking on disaster management and earthquake engineering. And today I deem it even more special because, I'll be speaking before a few of the eminent speakers and after a few of the fabulous lectures which we had over the last 2 days. So that gives me a lot of pleasure and honor. So with this brief note, I'll share my screen.
Go for share screen.
Yeah, in that screen sharing.
Yes, sir. Share screen.
Yeah, share screen. Okay.
Entire screen, sir.
Where is that? Yeah, entire screen. Share. Share.
Now, open your PPT, sir, please.
Yeah. Okay. Please tell me whether my PPT is visible
Yes, sir. It's visible, sir.
and am I audible?
Yes, sir. You're audible.
Okay. So once again, very good morning, everybody. We had a number of very good lectures over the last 2 days. Professor Tauhata spoke about, geohazards, and then we had four lectures by, eminent speakers in the area of disaster management, who spoke on the general aspects of disaster management. So I thought, I'll slightly take you over to the technical aspects, and I'll be talking about basically earthquake engineering. I thought, I'll show you a number of pictures. My presentation is through pictures, and most of these pictures are taken from various sources. And since it is for the dissemination of knowledge, I feel it's a privilege to take these things, and I sincerely thank all those who have provided them. Friends, I always try to say that, civil engineering and infrastructure are together. So if you just think of infrastructure all over the globe, huge amount of infrastructure are existing, and huge number of infrastructures, are also being constructed. Just Google search and you will see a number of infrastructural projects in India. And some of them, I have just listed here. See, it could be Bharatmala project. It could be, connection between Mumbai and New Delhi through Ahmedabad city, or National Highway project. Several projects, each of them is worth several lakh crore rupees. And as I said earlier, generally, whenever we say infrastructure, automatically construction industry and hence civil engineers will immediately come into picture. And whenever we talk about infrastructure, what we want is a very economic, safe, and today we also talk about sustainable infrastructure. So construction industry has to provide all these things. And one more important thing which we have all been talking about is urbanization. Lot of migration from villages. Our cities are being overcrowded. Just yesterday we had the statistics given. During independence, 16% of the country lived in cities. So if the population was about 35 crore, approximately about 5.6 crore people lived in cities. Today, more than 40% people live in cities. And today's population is 140 crore, which amounts to 56 crore people living in cities. So just imagine over the last 70 odd years, from 5.6 crore, it goes to 56 crore. That means every city in India is being overcrowded by 10 times in about 72, 73 years. So we need to provide, facilities. We need to provide infrastructure to deal with all these things. And every year, cities are being further overcrowded. Even today, migration is happening. Migration may be for in search of jobs, or in search of facilities, in search of infrastructure. So if you just see the budget of any country, including India, huge amount of money is being put for infrastructure. Even what our honorable prime minister mentioned during the lockdown period, or even during the latest independence day speech, he mentioned about infrastructure. So a lot of things have been done at the national level to make urban infrastructure more stubborn, more robust, sturdy. In this regard, smart city, clean city, safe city are some of the important policies. So if you just look at safe city, safety with respect to law and order is one aspect. Safety with respect to reduction in accidents is the other aspect. And the third most important aspect is minimizing the loss, minimizing the economic loss as well as loss of life during disasters is the third aspect. And this is what we focus on in today's lecture. Today's cities, as I said, are being overcrowded, and only way you can develop them is by vertical growth. So you'll have cities like these, jam packed with tall structures. And of course, they may be orderly, or unfortunately, in many cases, something like this, very disorderly, haphazardly built. Imagine you have a city with, a number of people, and, the quality of construction, something like this. And there is some disaster, like an earthquake, heavy rains, cyclone, or even flood. Will we be able to save life, sustain those buildings, or will we crumble is a big question mark. And if you just look at the earthquake scenario in the country, our country is broadly divided into four zones seismically very active regions coming in zone 5 or zone 4. Zone 5 is in red, zone 4 is in dark brown, or seismically least active is blue, zone 2, and yellow marks zone 3. So majority of our big cities are in zone 4 and zone 5. And we have had our share of bad luck over the past, and many earthquakes have happened in recent times, which I have listed here. I always say this earthquake of 2001 in Bhuj or Gujarat, was an eye opener. In fact, all of us woke up about the importance of disaster management after this earthquake. Then we had the 9.1 magnitude earthquake in Sumatra, which caused maybe about 10,000 deaths in India also because of tsunami. We had Kashmir earthquake, Sikkim earthquake, Nepal earthquake, and many more. But these were the ones which caused huge amount of problem to the infrastructure. So if you look at zones 4 and 5, which are seismically very active, 29 of Indian cities, including our Indian capital and 9 state capitals, are in zones 4 and 5. Delhi, Patna, Srinagar, Kohima, Puducherry, Guwahati, Gangtok, Shimla, Dehradun, Imphal, Chandigarh are these cities. Another interesting statistics was provided day before yesterday by Professor Tauhata. He, calculated the number of earthquakes. He just took the data of number of earthquakes, probably over the all over the globe, and then listed them in the graph here in terms of magnitude of earthquake and the year in which the earthquakes happened. Very interestingly, in 1950s, 60s, and 70s, Earth was very angry. We used to have more big earthquakes. And around 2000 onwards also, the intensity or magnitude of earthquake, has started increasing. But sometime between 1970s and 2000, for about 25, 30 years, Earth was relatively silent. So this is the graph which he plotted, showing that this was the period when we had reasonably still period. We didn't have too many big earthquakes. He also showed it in terms of earthquake energy, amount of energy released by the earth. Here also, between 1970 and 2000, the map, the amount of energy released is considerably less. So, what does it indicate? Does it mean that after 2000, the magnitudes of earthquake is increasing? Should we be seriously considering this? In 2011, Japan had its biggest earthquake in terms of magnitude 9. It killed over 25,000 people. I'll be showing you some of these slides on that also later on. He also showed another example in which, he considered the effect of rain. He showed that Hitoyoshi city in Japan, in Kyushu prefecture of Japan, had some time back in 2020 huge amount of flood. The flood water, grew up to this level. Can you imagine? So he said that actual flood level was much, much higher than the design flood level. So that means, even the flood, this is what he said. So this is the lamp post, and you can see lamp post, and you can see, some of the grass here, which is collected by the flowing water. So water was flowing up to this height. So that means, this was the level of the flood water. So the city was never designed for water up to this height. So even rain also, it appears to be in excess beyond the year 2000. So imagine when there is an earthquake, and in case the buildings are not properly built, we'll have a situation something like this. We'll have a situation something like this. So, do you think that it is the earthquake which kills people? Or is it our buildings that kill people? You can imagine what has happened to these buildings, People are simply walking on this debris. If it is our buildings that kill people, then are we civil engineers at fault? This is what we have to look at. And hence, if you cannot stop earthquakes, it's not in our hands. We'll have to look at the other thing. If these buildings are killing people, then how do we build buildings which do not kill people? How do you build buildings which do not fall? And then comes civil engineering. Well, we had sufficient amount of talks on disaster management. Here, only thing I want to mention is that there are many components of disaster management. Some of them are done before the event. Some of them are done after the event. But in each of these, civil engineering is involved. So civil engineers have a very big role to play in disaster management. You take mitigation, so reduction in the damage. So we need to work together to think of all those methods by which we can mitigate the damaging effects. Preparedness. You should prepare the buildings in such a way that you're always prepared for the next earthquake. You're always prepared for the next disaster. So there again, civil engineering comes into picture. After the event, response. So one of the immediate responses is repair. So already building has, been damaged. Some of them even may have collapsed, and our job is to repair them. And then think about retrofitting. Think about strengthening. Think about making them stronger, further stronger. So there again, rebuild. So there again, civil engineering is involved. Every component of disaster management, civil engineers have big role to play, and that is what I want all the participants to realize. And I always use a simple equation for disaster. Disaster is hazard plus risk. Hazard is something which you cannot stop. It is not in our hands. It is nature which provides hazard. If it is earthquake, we can't stop earthquake. We can't control earthquake. We can't reduce the earthquake. Okay, whatever magnitude it comes from. But then, risk is what we create. So disaster can happen only when both hazard and risk are high. Our job in disaster management is to bring down the risk to minimum, if possible, to zero. But then, we have all kinds of uncertainties which we have created by ourselves. Risk is man-made. We have pollution. We have population. We have unscientific growth. We have, haphazard industrial development. There is lack of space, not properly organized, environmental pollution, lack of greenery. You can keep on listing. If we can cut down these risks, I assure you that a hazard cannot be converted into disaster. Many lives can be saved. Even, big infrastructures also can be saved. So huge economic loss can be controlled. Day before yesterday, the Joint Director, Lieutenant Colonel Vashishta, was mentioning about the strategic plans in disaster management in the NIDM, and he said, 7 pillars. He listed these 7 pillars, and I tell you, in each of these pillars, civil engineering is involved. Prevention, you have to prevent the damage, you have to prevent the collapse of the building. So that is done by civil engineers. Mitigation, you have to reduce the damaging effect. You should be prepared. You need to capacity build. You need to repair and reconstruct. All these things involve civil engineering. So friends, therefore, we will have to look at disaster management in a much different way. I always try to show this slide to youngsters, to just define what an earthquake is. Okay, and somehow I feel that it can make some impact. Earthquake in general is the vibration which you see at the surface of the earth. Please note that the vibration is three-dimensional. Okay, it can act in north-south direction, east-west direction, up-down direction. And why does this vibration happen? Because at some depth below, which we call as focus or hypocenter, there will be disturbance. Earth is always under stress. And when the stresses exceed strength, there will be some explosion. There will be some disturbance. And this disturbance creates waves. These waves move in all directions. Those waves which move horizontally or downwards, will die after some time because of the damping effects. But those waves which move upwards or inclined upwards, when they hit the ground surface, will cause vibration. And when they hit the ground surface, there will be new types of waves called surface waves, which are also generated. All these put together will cause vibration at the ground surface. And this vibration, how our buildings, how our infrastructure withstand, is a big challenge. And if this vibration is very large and for a long duration, naturally it can cause quite a lot of problems. And we just cannot predict when the next big earthquake happens, what its magnitude would be, at what depth it happens, and how long will be the shaking. So here, please note, focus or hypocenter is the point or the place at which the disturbance happens. Point exactly above it, projected at the ground surface, is epicenter. The distance between them is focal depth. You may be anywhere. How far you are from the epicenter is measured by epicentral distance. These are some of the terminologies you should be familiar with. So you have the Earth mass, like this, and then the disturbance happens somewhere here, and this is the point where the disturbance happens, which is called focus or hypocenter, and then this is the epicenter. The distance between these two is called focal depth. Well, friends, with this brief note, I'll be talking about some of the earthquakes which have happened in India, Haiti, Nepal, and Japan. I'll try to quickly show you some pictures of floods and cyclone. Basically, my objective is to show what kind of dynamic force an earthquake causes, and we'll try to very briefly see how we can control it. This is what I have in mind. I just take you on to this earthquake, Bhuj earthquake, which happened, almost 20 plus years back on the Republic Day in the western part of Gujarat, close to Bhuj. The magnitude was 7.7, sufficiently large. Focal depth, I just now showed you, was 16 kilometers, shallow focus. There is also another terminology called intensity. The maximum intensity was 10 on modified Mercalli scale. The casualties included approximately about 20,000 deaths. Official figure is about 16,000. Several lakh people were injured. Several lakh people were rendered homeless. Huge number of houses were destroyed, damaged, and amounting to many economic loss, huge amount of economic loss, amounting to 1.3 billion US dollar loss. Well, there are many, pictures you can have from this. Some of them I'm just showing you here. This is a small town, okay, near Bhuj, Rapar town. See what has happened. People were getting ready for Republic Day celebrations. Children had moved to the schools for Republic Day celebrations. Probably people were, switching on the TV to see the Republic Day speech, Republic Day parade in New Delhi, and so on. Everything was normal just before the earthquake, just before it touched 9 o'clock. And when the earthquake struck, this is what happened. Everything is reduced to debris. Might be far away, you might see a couple of buildings. These buildings also, I tell you, are severely damaged. Look at this village called Bachao village. What is there now? Life was normal just before the earthquake, and it has been shattered. So even the hutments, all of them are completely destroyed. I'm very sure whoever is living here now will also be shouting, crying, asking for help, bachao, bachao. I then take you on to this earthquake. So this earthquake happened, about 11 years back in 2010. This is in Haiti. Okay. And very recently, 1 month back, also there was an earthquake in the same place, Haiti. Okay. And Haiti is a very small country in North America. This is the map of North America. And then, this is United States. And the southern states here are, this is Florida. Okay. And this is Mexico. Just to the southeast of Florida, a number of islands are there, including our West Indian islands, Cuba, and one of the small islands has, this country called Haiti. Its capital city is called Port-au-Prince, and here, very close to this Port-au-Prince, an earthquake of magnitude 7 struck about 11 years back, which had a focal depth of 13 kilometers, and maximum intensity mentioned is 10 on modified Mercalli scale. So what I want to draw your attention to is Port-au-Prince had a population of 30 lakhs before the earthquake. After the earthquake, 2.5 lakh people perished. That means, 1 out of 12 died in that city because of earthquake. And 3 lakh people were injured. When I say injured, they were severely injured. They will never get back their normalcy. So almost 1 out of 6 was reduced to nothing during this earthquake. So you can imagine what is the kind of damage an earthquake can do. So just see the infrastructure, what has happened. This is the central business area. There is no building which has survived. Every building is destroyed. So if people want to rebuild this, first of all, they have to remove the debris and then, think about rebuilding, think about bringing the materials, technology, knowledgeable engineers, everything, and rebuilding. Look at what has happened to road infrastructure. You can't use it as it is. It needs complete revamping. Look at what has happened to other kinds of buildings, whether it is a frame structure or masonry structure. Normally, we say that the buildings built for VIPs will be strong, sturdy, stable. In this case, the president's palace also suffered. You can see the dome portion here. Lot of indirect sufferings do happen during earthquakes. One such sufferings is, dust caused by the falling buildings. And this dust, continues to remain for days, weeks. And then fire. Fire can happen due to, either gas leakage or short circuiting. And in this case, fire broke out. There was nobody to extinguish this fire. For days, it went on consuming um, other infrastructure and also causing lots of problem to the people. Normally, what is required in disaster management is how quickly you can bring back normalcy, especially what we call as lifelines. Could be, drinking water, could be electricity, communication through a telephone, mobile phone, road. They should be, quickly brought back to normalcy so that, people do not immediately feel the, problem. In this case, even after 2 years, they did not have the infrastructure to remove the debris. Just imagine people already suffering. That day will be a nightmare. And every day they keep seeing this debris. What will be their psychology? Just see these young boys, how panicky they are. They do not know about their future. They just do not know what happens next. That is a kind of problem a disaster like earthquake can create. And the job of every one of us is to see that such disasters do not happen. We citizens should not feel the impact of it so severely. And that is what is disaster management. And when we have a problem, some time back, we should learn a lot of lessons from them. And then, come back stronger and, better to face the next, disaster. In this case, very recently, 1 month back, this earthquake happened. Again, magnitude 7, Haiti only. And, the statistics I have is about more than 2,000 people killed, 50,000 plus people injured, many houses again damaged. You just imagine one house, you take your entire life to build your home. Many people don't even do that. And if that is damaged, what will happen economically to that entire family? So then also they had many houses damaged. And over the last 10 years, I don't know somebody if they have rebuilt, and if their house again is damaged, you can imagine the situation. Okay, large number of infrastructure, bridges, schools, hospital buildings, office buildings, they were also severely damaged or destroyed. So these are all the lessons, and this is where the knowledge of disaster management should be imparted to everybody, and we all should fight together, work together to reduce the damaging effect. Just want to bring some statistics here. You have earthquakes. Okay, I just collected earthquakes of similar magnitude and similar focal depth. So the amount of energy at the ground surface is nearly the same. Okay, and hence, the damaging effect also is supposed to be the same. So I have considered three countries: Haiti, India, and then Japan. Just now I spoke about Haiti. So 12th January 2010, this earthquake of magnitude 7 happened and killed 2.5 lakh people. Magnitude 7, focal depth 13 kilometers. I also talked about Bhuj earthquake, where we had, magnitude 7.7, focal depth 15 kilometers. But then the number of deaths was less than 20,000. Why so much here and less here? I always say that it is because of the knowledge of disaster management. It is because of the awareness. It is because of good engineering practices. It is because of good knowledge of earthquake engineering. If at all we have done better, it's purely because of good awareness. It is purely because of disaster management. So we should feel proud that, we are not lagging behind too much when compared to countries like Haiti in terms of disaster management. And maybe over the last 20 years, we must have picked up also to a large extent. But then, I also want you to compare with Japan. Japan is a country affected by many earthquakes. Every year there will be 1, 2, or sometimes even 3 big earthquakes. Just see here, 2006, 0 death, magnitude 7.9, 2007, 1 death, 2008, 12 deaths, 9-0 death, 10-1 death. All of them had magnitude around 7, focal depth around 15 kilometers. Why so less here? It's purely because of the knowledge of earthquake engineering, purely because of better construction habits. As I told earlier, it is not the earthquake which may kill people, it is the buildings that kill people, because buildings fall on people's head, and hence casualties do happen. Here also I have the statistics, please go through here. Different countries all over the globe, the date on which the earthquake happened, magnitude and number of deaths. Just count where the number of deaths is less. It is one here, USA, one here, Ryukyu Island in Japan, 185 here in Canterbury in New Zealand. These are the countries which are doing very well in terms of earthquake engineering. These are the countries in which, good knowledge about seismic design exists, and hence number of deaths is less. But look at, Haiti, look at the Sumatra earthquake, which killed 2.26 lakh people, or Iran, India, Taipei, Turkey, Nicaragua. Again, Japan here. I have purposely put this. How many people died here? 1.23 lakh people died in Tokyo. But look at when it was, when this earthquake happened. It happened, almost 100 years back. During that time, we did not have earthquake engineering. During that time, we did not have disaster management. Out of 1.23 lakh people killed, 50%, almost about 60,000 people were killed by the fire accident. You all know that in Japan, people use wooden houses. Today, they use treated wooden houses. Therefore, it doesn't catch fire easily. But then, 100 years back, they were not having this facility, and hence, majority of the deaths happened because of the fire. I quickly want to take you on to this earthquake in 2011 in Japan. It's called, Great Eastern Japan earthquake. It is also called Tohoku earthquake. This happened in sea. The closest city was Sendai, less than 100 kilometers, and Tokyo was towards southwest of the epicenter by almost 350 kilometers. This is the earthquake motion. Normally, for a civil engineer, it is very, very important. On the vertical axis, there will be ground motion, usually acceleration, sometimes velocity or displacement. On the horizontal axis, there will be time. The duration of shaking is mentioned. Normally, you should know that whenever an earthquake happens, initially the motion will be of lesser magnitude of shaking, and at the later part also, it will be relatively still. Sometime in the middle, there will be rigorous shaking. That we call a strong motion part, which normally in a big earthquake is for 10-15 seconds. But here in this earthquake, the total duration of shaking was almost for 5 minutes, and then the strong motion part itself was for almost 1 minute. So that shows the rigorosity of this earthquake. Uh, Magnitude was 9, that is the biggest Japan has suffered. Unfortunately, it killed about 25,000 people. And, it was so powerful that Honshu Island, which is the biggest island, it's approximately 1/10 of India in area. This was moved by 2.4 meters. The shaking continued for 3 to 5 minutes. It had many aftershocks. Some of them had magnitude 7 and above. Well, the biggest, damage this earthquake created was tsunami, because the earthquake happened in the sea, at the seabed. The seabed, cracked, and therefore waves were generated, and these waves moved at very high speed, maybe at a speed of an aircraft, towards the shore. And the first shore it came across was close to Sendai city. And hence, when these waves at high speed hit the shore, naturally huge waves are generated. Waves of the order of 20 meters or so were generated. And this is how the tsunami would be. And these waves, when will try to hit everything that come in their way. It could be a building, it could be tree. If the building can withstand that, okay, it survives. If not, you'll see something like this. The city normally, which will be very organized in Japan, it is so messy. You can see, this is the typical building in which people live, wooden houses, and probably that survived the earthquake, but that could not survive the tsunami. You can see the tsunami water, sea water having entered the city, and what has happened here. Very quickly, I would like you to see what happens due to tsunami. These ships perhaps were bored being in the sea. They wanted to see what is there in this city town. They have come. You can see the ships along with the motor cars. Here, these are the dikes built. So Japanese already always have the planning. So they had built their dikes, for a height of about 5 meters, and they survived many tsunamis. But then, unfortunately, these tsunami waves were much bigger than 20-meter in height. Therefore, they simply yeah, overshoot these dikes and went into the land. These boats are trying to go for a high jump. Unfortunately, they missed the bus, so they have to remain in the sea region only. This is the situation in the airport, Sendai airport. You can see the amount of water over the entire airport. And then, this water goes upwards till it loses its speed, and then, goes back to the sea. So when it has gone back to the sea, you can see that it has left huge amount of silt here. On the runway, there was silt for a thickness of about 1 meter or so. So they had to, remove that silt and then, clear off the space for aircraft maneuvering. You can see here, this looks like toy place. So all aircrafts and, motor cars dumped at some low-lying area. So all these things are possibility during a disaster like earthquake and tsunami. One other serious problem which happened was the, you know, what should I say, damage to Fukushima nuclear power plant. So we also have power plants, Kaiga in Karnataka, and then, we also have in Tamil Nadu. So, the waves came and hit this nuclear power plant. This power plant could not withstand this wave, and hence, it blasted, causing huge amount of nuclear radiation. People say that this nuclear radiation was one of the worst, second only to Chernobyl radiations, which happened sometime in 1980s. So Fukushima radiation was another serious disaster which happened after the earthquake. Earthquake caused tsunamis, tsunami caused nuclear radiation, indirect effects. Still, what we have to appreciate with these Japanese is that they brought back normalcy as quickly as possible. So cities which looked something like this, were converted into everything comfortable within hardly a couple of months. Well, friends, we in India also suffer from severe earthquakes. As I said earlier, there have been many occasions when we have had big earthquakes in the recent past. And one such earthquake I always try to remember is Latur earthquake, which happened in 1993. Please note, Latur is not very far from Karnataka. It is on the borders of northern part of Karnataka, very close to Gulbarga, very close to Bijapur, Raichur, and so on, Bidar. Okay. And this earthquake of magnitude 6.3 struck earlier in the early hours on 30th October 1993. Unfortunately, it killed about 20,000 people. Again, official figures are much less. The only reason which we can quote here is that the buildings were not built to seismic resistance. They were never built considering the earthquake resistance into mind. Lot of stone is available there. Stone is generally strong, therefore people think, it is, when you build using stone, you can build stronger structure. But, you should also know that it is not just enough if if you use stone. You should know how to use it, how to see that, you key one stone to the other in such a way that even when you push, when you apply lateral force, it will not fall down. And in this particular case, these buildings were never designed for lateral force. And when an earthquake of reasonably big magnitude shook that city, the walls fell down. Roofs which were supported on the wall, they had no scope. They also fell down. It was early in the morning. People were sleeping. So before they realized what happened, they all perished. So almost 20,000 deaths. So not very far from Karnataka, less than 100 kilometers. And this is how the city of Latur looked. You can see this is how the city of Latur looked, clearly indicating that there is lack of knowledge in earthquake engineering. There is lack of knowledge in handling the horizontal force. So as I said earlier, the earthquake which causes huge amount of horizontal force, horizontal dynamic force, you know, um, it is unpredictable. We don't know what will be the next earthquake force, and our job is to design, or our job is to identify, understand what is the dynamic force caused by earthquake. Well, very quickly, Nepal earthquake. Nepal is again not far from us, so we should know. In 2015 April, there were two earthquakes: an earthquake and its aftershock. Earthquake of 20 of magnitude 7.9 on 25th April. 15 days later, 7.4 magnitude earthquake. And this earthquake killed more than 10,000 people, focal depth 15 kilometers. And the first earthquake had a magnitude, intensity more than 9. And it happened in between these two cities, Pokhara and Kathmandu. Also, not very far from the base of the Everest. So, this is the place, and a number of aftershocks did happen close to Kathmandu city. And this earthquake is due to plate tectonic theory. So plate movements, Indian plate moving under Eurasian plate. And hence, some of the places which were low lying, were lifted up, and some of them were lost their height, lost their altitude. And this is what happened when Indian plate subducted into the Eurasian plate. This entire area was lifted up. So this reference point also was lifted up. This is how this entire plate is going down below the Eurasian plate. So some portions are moved up, and some portions are moved down. And all of you must be knowing that our globe, our Earth is never stationary. Continuously, some activity is happening. And Indian plate or Indo-Australian plate, what we say, is continuously moving northeastwards at a rate of around 5 centimeters, 2 inches in 1 year, almost at a rate at which our hair grows. And because of that, epicenter is here. Some portions were lifted up. These portions were lifted up by more than 1 meter. And this portion here was brought down by more than 1.5 meters. Today, we have the technology, we have capacity to predict. USGS predicted that, approximately 33% possibility 10,000 people will be killed, and 35% probability that, this is the amount of loss, some 10,000 million US dollar loss, and the prediction was perfect. So a picture of a road, having a crack here because of the fault formation. This was one of the beautiful tourist center, Darhara Tower, which was simply reduced to, debris like this. Some 200 people who were visiting this tower as tourists, perished. Well, I just thought I will show you a video of how situation would be during an earthquake. These many CCTVs in Kathmandu have taken these pictures, and I just want you to see how people are anxious. People do not know what to do. Okay, and everywhere the vibration, this entire mass, heavy mass, is also vibrating, and so wherever you have unstable situation, tall statues, etc., you have the problem. And here you can see people are moving around. Suddenly they realize the earthquake, and probably people were clever. They felt that buildings are dangerous, So all of them have come to the center of the road, and some people, have taken more time. Luckily, these buildings somehow survived. So this is what happens. And very quickly, I want to show you how earthquake force is slowly generated. So I said, initially shaking will be slow, suddenly it becomes vigorous. But to make all others also shake, it takes some time. This is the swimming pool in a hotel, and you can just see here, shaking has already started. So CCTV is capturing everything, but the water here is still. And I just go a little quickly because I don't have much time. Water still looks still. Now also shaking is going on. Okay, you can just see here shaking is going on, and still water has not shown the amount of shaking. Slowly the shaking is building, the energy is being transferred to water, and you can just see after some time how the waves are generated. So these waves, can really cause huge amount of force on the building, and our building should be able to withstand that. Just I want you to know what kind of force an earthquake can generate. So unfortunately, statistics says that out of all the natural disasters, it is the earthquake which kills maximum number of people. It is the earthquake which causes damage to buildings to the maximum extent. Very quickly, flood and hurricane also have similar problem. We have a problem with flood, almost every year. Uttarakhand during 2013, more than 10,000 people were killed. This is Alaknanda river, tributary of Ganga. You can see how ferocious it is, and how it has eroded the surface here. So effect of that, some landslide somewhere, and hence these uh, vehicles are stranded for maybe days, sometimes even weeks. Again, erosion in Rudraprayag, Alkananda River. You can see the soil erosion. So water has come up to this level. Okay. Very recently, in February this year, one of these glaciers, Nanda Devi Glacier, which was there, it fell down. So it fell down, causing huge amount of outburst in again Alkananda River, Joshimat. So that destroyed one of the Hydel projects also. Well, Karnataka is also not free from floods. Every, often, especially in the northern Karnataka, will have flood. You can see how ferocious this Krishna River is. It is meandering, and then, it has already crossed the banks here and into the habitation area. So, the effect of flood on the infrastructure, railway infrastructure, road infrastructure, cyclone, which is a common problem. Okay, this is in Bangladesh. You can see relatively temporary structures, their fate. So naturally, the citizens will be in total panic. This was one of the biggest, you know, cyclones to have struck India in Orissa in 1999, more than 10,000 deaths. And these natural disasters do not know whether they have to strike a developed country or a developing country and so on. So this is what happened in New Orleans after the Katrina hurricane in 2001. Most of the infrastructure was severely damaged. Well, friends, I'll quickly spend a little time on earthquake force, and quickly on to what can we do to build our structures to be earthquake resistant. All of us are familiar with dead loads and live loads, which all act vertically downwards, and these are static forces. So you can design your members, slabs, beams, columns for these vertical static loads. But whether it is earthquake, flood, hurricane, cyclone, or tsunami, they cause horizontal force. They cause lateral force, which is dynamic. And that's the major difference. Wind generally hits the exposed surface. It is something like, somebody slapping you on the face. Whichever surface is exposed, it will hit. What does earthquake do? Earthquake always works at the base. It's something like, you are standing on a carpet and I pull the carpet from below. That is what happens to the structures. So when you have a lateral push, naturally all the portions which have mass, they show inertia. So the joints are subjected to inertial forces, and you need to build them to withstand it. You need to compute what is this lateral horizontal force, the dynamic force, and build the structure to withstand that. So generally, under a horizontal force, when you have a wall, when you have a vertical member, so it is subjected to horizontal force. So it may cause sliding, it may cause overturning or rocking, or if it is firmly held, it might even cause bending. So you need to design the structure to withstand these effects. Normally, we all know how to evaluate, estimate the total vertical load. Please note that the horizontal force due to earthquake is a dynamic force, therefore, this H is dependent on time, and it is also dependent on the vertical force. If this force is more, horizontal force is also more. So, friends, you should realize if you want to reduce the horizontal force, keep this W also less. So, lightweight structures perform better during earthquakes. And this horizontal force to which you have to design depends upon the area, the region in which the building lies. As I told earlier, it all depends on the zone in which it is lying. So you have zone 2, which is seismically least active, and then zone 5, which is seismically most active. And very quickly, the difference between an earthquake and wind. Earthquake force always, vibration happens with respect to zero mean. Therefore, a push in one direction, and next force will be pull totally in the opposite direction. Wind at a given time acts only in one direction. It may be a dynamic force, but acting only in one direction. That's the major difference. Therefore, earthquake causes much more severe problem, and buildings are more vulnerable during earthquakes. So this is what happens during earthquake, building at rest. And one time the push is from right to left. Therefore, the base is pushed, but the other part of the building are not interested in moving. Therefore, they show that inertia like this. If the building has flexibility like this, it is okay. On the other hand, when the push is on the other side, it will bend in this manner. So if you can build a building which is more flexible like this, perhaps it is earthquake resistant, but you can't make it flexible like this. Very quickly on to acceleration. Whenever I talk about dynamics, I always have to talk about acceleration and mass. These two are very important, and hence inertia. Always we love acceleration. You go to Disneyland, you go to those places where you have attractions and you want to go in the roller coaster, or maybe you want to get down through a parachute, and all these are thrilling. Why? Because we get excited with acceleration. And these are some of the levels of accelerations you can see: 1G, 4G. Even if you shake hands with people, you will generate some amount of acceleration. And just think of the fastest cars, formula cars. They may generate acceleration in speed from 0 to 160 kmph in about 4 seconds. Find out how much is the level of acceleration they create: about 10 meter per second squared. A ordinary Indian car, which can accelerate in about 20 seconds from 0 to 100 kmph, can generate an acceleration of around 1 to 2 meter per second squared. But what does earthquake do? The biggest of the shaking, biggest of the accelerations recorded is 30 meter per second squared in all the directions: north, south, east, west, and up, down. So that is 3 times that of acceleration created by fastest car. So that's the level of force an earthquake has. Very quickly, the difference between static and dynamic force. I have tried to plot graph between the magnitude of force and time. And if it is a static force, it has no dependency on time. Whether it is measured initially or at the end, it remains the same. But you have dynamic force, blue line in which rate at which the force is increasing with time is less. Red line, force increasing is very rapid. This is definitely more dangerous. But what earthquake does is something like this, green line. So it increases, reaches a maximum, and then comes down to zero, and it further increases, reaches a maximum, but in the opposite direction, comes down to zero. So it is always cyclic, repetitive. Imagine I'm pushing you continuously. You know that I'm pushing, therefore you know how to react. On the other hand, if I pull and push you alternatively, you your body as well as mind will have to work together. Sometimes you make a mistake. You are thinking that I'm pulling, but you try to resist, but it is the action in the other direction. So always cyclic forces make things more vulnerable, and that is exactly what earthquake creates, and we should be careful. Our friends, uh, you know, in the design, let us say that I have a cantilever beam. I know that it is subjected to vertically downward load. Therefore, the beam experiences a bending like this with tension at top. Therefore, if I make an RCC beam, I provide the steel at top. Imagine that it is subjected to alternate loads. Load which is dynamic, which acts for say downwards for some duration of time, upwards for some duration of time, and that is what is kind of dynamic force. And when that happens, it goes down and down like this, and then it experiences the shaking in the other direction. What should you do? You have to compute what is the maximum bending when the force is downwards and provide reinforcement at the top in an RCC building equivalent to that bending. And you also compute what is the maximum bending in the upward direction, and accordingly you provide the reinforcement at the bottom. So, what you need to do from the point of view of earthquake is your basic knowledge of civil engineering is okay. Only thing is you have to add a little more. You have to really rationally think and provide modifications accordingly. So you don't need to panic that you have not studied earthquake engineering. You just have to understand, okay, what earthquake does, and accordingly you need to prepare yourself. Uh, I just try to take 1 or 2 minutes more and then go to the last slide. One very important philosophy in earthquake engineering is you do the design in two stages. Stage one, you design for an earthquake which may happen many times during the life of the structure. Under this earthquake, the member should never experience, the component of the building should never experience, plastic failure. It should, come back to its originals. It should be within the elastic stage. It should never fail. On the other hand, level 2 earthquake is something which may or may not happen during the life of the structure. All those which I showed were level 2 earthquakes. So, Bhuj earthquake, which happened in 2001. When will the next earthquake be? We do not know. Maybe 100 years, 150 years. Okay. Should we design all structures to withstand that? Very expensive it becomes. We are all engineers. We should be doing things intelligently. So, what we do is under this earthquake, the building can be allowed to fail, but it should fail with warning. What do I mean by this? You should be allowed to go out of the building. You should be given sufficient amount of time to go out of the building and see how the building falls, how the building fails. That is what we call as ductility. So we should have the building imparted ductility. I always try to show WTC collapse and tell you it's a very good design. Almost 40 minutes after the collision of the aircraft, the towers came down. That means, they are ductile enough. So with this, I close my lecture. I had a few, lessons about, earthquake resistant construction, but these are all available. And I need to give some time for discussion also. I'm very sure my good friend Professor Chandan Ghosh will be ready waiting for. So I close mentioning that earthquake resistant construction is very, very essential. We need to think about making our structures, you know, I wouldn't say earthquake safe, earthquake resistant, earthquake proof. I wouldn't say earthquake proof. So depending on the magnitude of earthquake, the performance should be different. Very big earthquakes, it's okay even if they fail, but they should fail with warning. Small earthquakes, they should never fail. I take this example most of the times, Bunga. This used to be the buildings of the past in Gujarat and Rajasthan, 100, 200 years back. After 2001 earthquake, NGOs built these bungas and said, these bungas built by engineers 200 years back, they survived many earthquakes. But today's buildings built by you civil engineers, they have failed. So they wanted to criticize civil engineers. I usually give some time to people to react, but now it's online. So I always say, don't be panicky if that happens. You always should be proud to say that I am a civil engineer and many civil engineers have done wonderfully. Today, if you build a bunga like this, nobody would like to live in such buildings. We want buildings which are tall, which are handsome, which are beautiful, which have lot of open spaces, which have lot of projections, which are unsymmetric. We are able to build them and still make them earthquake resistant, but sometimes we may fail, and that sometime we should minimize. So don't be panicky if people say it is the civil engineers who kill people, it is not the earthquakes. This is one again structure which interested me. I got it from a magazine after 2001 earthquake. This was in Ahmedabad. Many buildings in Ahmedabad city, more than 250 kilometers away from the epicenter, they were destroyed. They were all recently built, only 5-10 years back. Most of them were apartment buildings. This was one such 5-storied apartment building. Entire building failed except the lift portion. This is what is earthquake resistant construction. Maybe the engineer was careful when he built this lift portion. He built on 4 columns. He just forgot to connect them properly to the other parts of the building. So this is what is earthquake resistant construction. We have to build the entire structure, entire building, to be something like this. So with this, I close my lecture. Very quickly, I'm giving these points. Yeah, motivating engineers to update knowledge of disaster safe, especially earthquake safe construction is important. We have to collect the codal provisions and materials related with, earthquake safe design. We need to have well-equipped rehabilitation centers to safeguard people during the crisis. We need to create awareness among general public to hire experts who design and construct according to the disaster requirements. Expertise in assessing the capacity of existing structures, okay, and possible retrofitting is essential. Disaster engineering experts perhaps may be requested to issue license for new constructions, just like we do it for general planning and sometimes for soil testing. And we need to keep records of past failures. With this, I close my lecture mentioning that we have all the components of the buildings which are important. I always say foundation is the most important one. It should rest on strong, stable ground. And you need to design the components according to their order of importance. Foundations are most important, followed by columns and then beams and then slabs. All structures should be designed and constructed for ordinary load plus extraordinary load like earthquake. Periodic maintenance of the buildings is essential in earthquake-prone area. Emphasis on safe city, plant construction, controlled population, and most importantly, disaster management is very, very important. With this, friends, I close my lecture. I thank each one of you for your patient listening, and it's a pleasure. It's a pleasure to associate with the other panel members for your questions. Thank you, one and all.
Sir, thank you very much, sir. It was really an informative session on earthquakes and its mitigation. It was a great learning session and a great beginning for day 3 of this online training program. Thank you very much, sir.
Thank you. Thank you, Professor Raghavendra.
Okay.
A gentle reminder, dear participants, post your questions in the chat box and give your valuable feedback to the link provided in the chat box. Now, today in this session, we have our panelist, Dr. Chandan Ghosh from NIDM, Dr. Umesha PK from VVCE, and Professor Rajit from the College of Engineering. I request the professors to handle the question answer session. Please, sir.
Yeah, I
Yeah,
just
yeah.
request Dr. Chandan Ghosh to take over.
Okay, okay.
Okay,
Thank you.
okay. Yeah. Thank you, Professor Prasad, for giving a very, very, very lucid presentation of disaster management, which, of course, NIDM carries the flag, but the kind of presentation that you have made, especially about the earthquake, to the young generations whom we are here, from the basics of classroom to the importance of preparedness, importance of resistant measures, giving a comparison between Haiti, India, and Japan, and taking out each and every example is a great testimony of not teaching disaster management, rather getting acquaintance with what it is that how building is making all this trouble that we are making. We civil engineer, we are all here civil engineer. Well, ultimately we see that we are to take the arrow in ourselves, in our own things, because buildings are not given, buildings are not being properly designed, even though design and everything is available. So anyway, Dr. Umesha, there are some questions are there. Yeah, if you want to make a quick comments on what your colleague.
Okay, okay. So, as usual, Dr. Eske Prasad has given very informative lecture on earthquake and what is a flood and how it will happen and what is the basics of that one fundamentals to our younger generation. It is very useful. I think it is he has given a lot of things. What is the difference between static and dynamic loading, and what is the difference between the wind load and as well as the earthquake load? All the things he has covered very nicely, and we'll appreciate his lecture. I think hopefully all our young generation
Thank you.
will have to generate this type of lecture. They have to see this little lecture, and it will be useful actually. And I think some questions are there. Shall we
Yeah.
take? I think one by one.
Yeah. Please.
Okay.
Yeah.
Sir, there is a question from Rajit from VVCE. Okay, can you explain some important steps to prepare for the survival and recover during the immediate and after earthquake?
Okay. In fact, that is another big lesson we can spend hours. Actually, myself and Chandan lived in Japan for
Okay.
years. We know what is to be done. Just to tell you, every year, at least 2 times in my
Correct.
locality, we used to have the what should I say, camps for preparing training. So they used to train everybody, an youngster of an age of 2 to probably a person of an age of 90, and the training was filled with fun also. So they would bring the fire engine from 6th floor. They would pick the child and bring it down, and they would make us go in a fire affected building. They create artificial fire and go in that. So basically, there are many warning systems. In fact, some of them which they follow in Japan is very, very interesting. Immediately after the earthquake, you can switch on the TV and know what is happening in your place. And if you are in a zone where the intensity of shaking is of the magnitude of, intensity of shaking is beyond 8 or 9 on Mercalli scale, you simply go under a sturdy desk, and wait for the signal from the corporation. They will probably make a public announcement saying that you stay back there only. Otherwise, you get down,
Okay.
not through the elevator but through the steps, and you go to the rehabilitation center. Everything is very, very organized. I must have experienced at least half a dozen earthquakes, and probably 3 to 4
Correct.
trainings
Okay.
like this, and that is what is important. So one is preparing from the point of view of civil engineering aspect.
Civil engineers.
You need to build your structures to be able to resist earthquake. One simple thing is blindly follow 13920.
Okay.
Okay, that means you make your building ductile. And the other aspect is all these things immediately after what is to be done. Anyway, we can spend a lot of time on that, but there may be many more questions. I'll try to
Sir,
answer them.
Yeah, one question from Rajesh Shekhar. Now he is telling how the ancient structures were constructed, which were earthquake resistance. What strategies were adopted? What scientific
Yeah.
principles were adopted by the earlier architect to build such temples?
Anyway, one very serious thing we all should know is I told you, I gave you an example of Bunga.
Correct, sir.
If you build bungas, today, I'm sure they will survive. Not
Correct.
just earthquake of magnitude 7, 8, 9, they will survive. Okay. Those ancient structures, they were extremely symmetric.
Okay.
They were also having large cross sections, very stable. And hence, they were also not able to just take vertical load. They were pretty strong against lateral force. We can't build structures like that today. We need slender, walls. We need lot of open space, and we need also space in the ground. Therefore, our columns also need to be very slender. So this is where the challenge is now. And today's structures, if we plan well and build, I'm sure they will also survive big earthquakes. Not a problem. So earlier ones, basically because of their geometry, because of their sturdiness, they were able to withstand. And today, if you build the same structure, of course it will withstand. And we are much, much better off than what we were maybe, 100 years back.
Okay. I think next is question I think I already answered. How can we replicate the same ancient buildings architecture to the present day? I think you answered that one.
Yeah.
Chandan Ghosh, I think, are you?
Yeah.
Okay.
I think
Take,
it is,
two more questions are there.
Yeah. So I would say that, of course, we are thankful to Raja Shekhar who has been
Okay.
very much kind enough to question not for himself only, but for the audience also
Yeah.
to know
Correct,
that
sir.
how questions are, and it is not for him only that that answer is given, but it is for all. So thank you, participants, for how can we replicate the same and say, okay, it is same.
Okay.
So
Okay.
in fact, he is very active in asking the questions.
Okay,
And
sir.
I hope that our participants and as well as the entire community, our civil engineering community, they are able to know that what is what, especially for earthquake resistant building construction. And building construction, in fact, which Professor Prasad highlighted, and we know, we have been also telling that it is not the earthquake, but the buildings do. And who makes the building? It is civil engineer. So in that case, whatever basic principles, as Professor Prasad said, 13920, which is there since 1993 onward. In fact, earthquake code is there since 1962 in our country. If we follow that, at least up to 7.5 magnitude earthquake or intensity 9 earthquake will not at least collapse our building. So that we have to make it through training, exercise, and practice, and a lot of awareness that we have to do. So thank you, Professor Prasad, for taking this lead as you have been always.
Thank you very much. Thank you. I think it is time
Yes,
we
sir.
shall
Yeah.
close.
Clarification.
We need to listen to Professor Chandan Ghosh. So
Okay.
over to you, Professor Rajit and Professor Raghavendra.
Thanks to all the professors for interactive question answer session. Now I request Professor Manoj P, Assistant Professor of Department of Civil Engineering, to propose vote of thanks. Over to you, sir.
And Professor Raghavendra, please don't forget to inform about shifting to another this one,
Yes, sir.
link.
Sure, sir. Sure, sir.
You can mention later on. Okay.
Yes.
Yeah. Thank you, Rangvendra sir. Good morning, everyone. As we have come to the end of the sixth lecture of online training program on fundamentals of disaster management, it's my privilege to propose the vote of thanks. On behalf of Department of Civil Engineering, Vidyavardhaka College of Engineering, Mysuru, and National Institute of Disaster Management, Ministry of Home Affairs, Government of India, New Delhi. I convey my sincere thanks to this session speaker, Dr. Eske Prasad sir, Professor and Head, Department of Civil Engineering, Vidyavardhaka College of Engineering, for sharing his valuable, wonderful experience and knowledge. Thank you, sir.
Thank you very much.
I thank Dr. Chandan Ghosh sir, Professor at NIDM, for gracing this occasion. Thank you, sir.
Thank you.
My sincere thanks to Dr. Umesha PK sir, Professor and Chairman of Research Studio, Department of Civil Engineering, Vidyavardhaka College of Engineering. Thank you, sir.
Thank you.
Okay.
I wholeheartedly thank our HOD for his continuous support and motivation in organizing such events. Thank you very much, sir. I also thank all the panel members, organizing committee members of NIDM and Vidyavardhaka College of Engineering. Last but not the least, I thank all the participants for your active participation in this session. Thank you very much.
Thank you, Professor Manoj. Now I request all the participants to join us in our next session on living with urban floods and affordable mitigation measures by Dr. Chandan Ghosh, Professor NIDM, Government of India, New Delhi. The link for the new session has been posted in the chat box of YouTube, as well as it has been posted in WhatsApp group of this program. Kindly click on that and join the next session. Thank you.
Thank you.
Okay.
Professor Chandan, you also will have to join on the new one.
Yeah. Is it given in the chat box? Okay.
No. For you, you must have got it on your either
WhatsApp?
WhatsApp or your email.
Okay.
You have it in your email. So just do you find it?
Only one. This one, current one, I am having.
No, the other one also must have come. You have two today. Otherwise,
Yeah. Just
you got it?
WhatsApp I wanted to have from Kanmani or this one.
If it's not there, I'll send you once again, sir.
Okay,
Yeah, please
Manoj,
send it. Okay.
please send him again. Please send
Yeah.
him again. Okay, and I will leave now.
Okay.
Manoj, send him again and send him